Lesson: Identity fraud detection using AI techniques. Identity fraud remains a significant threat in the digital age, with an increasing number of individuals and organizations falling victim to this pervasive crime. Utilizing artificial intelligence techniques for identity fraud detection within identity and access management systems offers a robust solution to combat these threats. AI-driven techniques provide actionable insights into identifying and preventing fraudulent activities, delivering a powerful toolset for cybersecurity professionals seeking to enhance their skills in the CompTIA CySA certification domain. The application of AI in identity fraud detection harnesses machine learning, natural language processing, and anomaly detection algorithms to effectively analyze vast amounts of data, identifying patterns indicative of fraudulent behavior. One practical tool employed is supervised machine learning, where models such as decision trees, support vector machines, and neural networks are trained on historical data to recognize fraudulent patterns. These models can be refined using techniques such as cross-validation and hyperparameter tuning, ensuring high accuracy in detecting fraud. For instance, supervised learning can be applied to analyze transaction data from financial institutions. By training a model on labeled datasets of known fraudulent and legitimate transactions, it becomes possible to predict the likelihood of fraud in new transactions. This approach is exemplified by the use of random forest classifiers, which aggregate multiple decision trees to improve prediction accuracy and robustness against overfitting. Implementing such models requires practical tools such as Python's scikit-learn library, which offers extensive support for constructing, evaluating, and deploying machine learning models efficiently. In addition to supervised learning, unsupervised learning techniques like clustering and anomaly detection play a crucial role in identity fraud detection. Unsupervised models do not rely on labeled data. Instead, they identify anomalies by detecting deviations from established norms. This is particularly useful in scenarios where fraudulent patterns are not well defined or are constantly evolving. Algorithms such as k-means clustering and isolation forests are commonly used to identify outliers in datasets, which may indicate fraudulent activity. Natural language processing further enhances the capabilities of AI in detecting identity fraud by analyzing textual data from various sources, such as emails, social media, and online communications. NLP techniques can extract meaningful information from unstructured data, identifying red flags such as phishing attempts or fake identities. Practical frameworks like the Natural Language Toolkit and SPACY enable cybersecurity professionals to implement NLP-driven fraud detection systems, providing tools for text parsing, sentiment analysis, and entity recognition. Case studies illustrate the effectiveness of AI-driven identity fraud detection. For example, a study conducted by a leading financial institution demonstrated a reduction in fraudulent transactions by 30% after deploying an AI-based anomaly detection system. This system utilized a combination of supervised and unsupervised learning models to analyze transaction data, successfully identifying suspicious activities that were previously undetected by traditional methods. Statistics further support the adoption of AI techniques in this domain. According to a report by the Association of Certified Fraud Examiners, organizations that implemented AI and machine learning technologies reported a 25% reduction in fraud losses compared to those relying solely on traditional methods. This underscores the tangible benefits of integrating AI into IAM systems for fraud detection, offering a compelling argument for cybersecurity professionals to adopt these techniques. Moreover, frameworks such as the MITRE ATT&CK framework provide a comprehensive knowledge base for understanding and mitigating identity fraud threats. This framework outlines various tactics and techniques used by adversaries, offering valuable insights into potential vulnerabilities within IAM systems. By aligning AI-driven detection strategies with the MITRE ATT&CK framework, professionals can enhance their ability to identify and respond to identity fraud attempts effectively. Implementing AI techniques for identity fraud detection requires a strategic approach, balancing technological capabilities with practical considerations. Professionals must assess their organization's specific needs, data availability, and existing infrastructure to determine the most suitable AI models and frameworks. Additionally, ethical considerations, such as data privacy and fairness, must be addressed to ensure compliance with regulatory requirements and maintain stakeholder trust. In conclusion, leveraging AI techniques for identity fraud detection within IAM systems represents a transformative approach to addressing the challenges posed by identity fraud. By employing machine learning, natural language processing, and anomaly detection models, cybersecurity professionals can significantly enhance their ability to detect and prevent fraudulent activities. Practical tools and frameworks, such as scikit-learn, NLTK, and the MITRE ATT&CK framework, provide the necessary resources for implementing these techniques effectively. Case studies and statistics highlight the substantial impact of AI-driven fraud detection, reinforcing the importance of integrating these technologies into IAM systems. As professionals continue to advance their skills in the CompTIA CySA certification domain, embracing AI-driven identity fraud detection will be crucial in safeguarding organizations against the ever-evolving threat landscape.